Hey folks, welcome back for another episode of Code Club. In the last episode, I shared with you a figure from this paper that was published in the journal M Systems, published by the American Society for Microbiology. The paper is titled L-tryptophan and copper interactions linked to reduced colobactin genotoxicity in PKS plus E. coli. If that means nothing to you, don't worry. Let's scroll down to figure 5, which is the figure that I was trying to recreate in that last episode. So where are you? Right there, figure 5D. And so this is a plot with, on the y-axis, having percent fluorescence. And so it's effectively the percent fluorescence where there's no copper added. So copper in the media is on the x-axis. So basically all these values to the right of my cursor here are relative to the value that I'm highlighting here with my cursor, right? The 0% copper. And so you'll see that they had 3 replicates for each of these experiments or each of these conditions, right? And they had 2 conditions. One was a control, which is shown in this orange, 7H4M, and then the experimental treatment, where they then looked at degradation of genotoxicity, is indicated with this kind of blue color, the CLPB17. So a couple things stood out to me about this figure that I didn't really like, right? So first of all, they're putting box plots on top of 3 points. So as you can clearly see above my mouse pointer here, if you have 3 observations and you put a box plot, the median point is obviously going to fall on the median, and the smallest point is going to be at the bottom of the range, and the largest value is going to be at the top of the range, right? And so the box plot, when you have 3 points, does nothing except, in my opinion, clutter up the visual, right? And so that's just unnecessary, right? The other thing that I was struck by is that these copper concentrations are largely on a log 10 scale, right? So you've got 3 times 10 to the minus 3, 3 times 10 to the minus 2, 3 times 10 to the minus 1, 3 times 10 to the first, and then 3 times 10 to the second power, right? So we're missing a value of 3, and we have this oddball 0.01 thrown in here, right? But why not show the data on a log scale? The data were collected using copper concentrations that were on a log scale. Why not show it on a log scale? As it is, it kind of gives the impression that all of these values are equally far apart from each other, which is obviously not the case. The other thing that I critiqued in that video is that we have these 2 conditions, right? The orange and the blue, for the lack of a better phrase for these treatments, that they're put separate to each other, and there's a bit of a dodging between the 2 box plots within a copper concentration. And that spacing is the same as the spacing to the next copper concentration, right? So if we had had more points and that would make the box plots make a little bit more sense, my preference would be to put the 2 box plots within the same copper concentration right next to each other and then have a gap to the next copper concentration, highlighting that the differences we're really interested in across the x-axis is the copper concentration, not which condition was being used, whether it's orange or blue, right? That the orange or blue are relevant within each of the copper concentrations. So I've been thinking more about this and how I would do this differently. And so I broke out my multicolored pen. That reminds me of elementary school where I can get 4 or 5 different colors in one pen. My wife makes fun of me about that. Yes, she does. Anyway, and I did what I often tell people to do, which is to draw out your figure before you go about trying to create it on the computer. And so what I've got here, again, on the x-axis, as I mentioned, is the data in a log scale, right? And so I'm putting 0.03, 0.3, 3, 30, 300. The other thing then that I would do would be to perhaps create a vertical dashed line here between the 0 and the 0.003. And that would kind of show that this is the reference point for everything else, right? That everything is relative to these values at 0% copper. And so as you can see, I've changed those black points to colored points that correspond to the 2 treatment groups. And then what I'd like to do is draw a line through all those points, right? So perhaps you could draw the line through the mean or the median of those different points. And I was kind of experimenting here. You can kind of tell where I was using maybe a lighter colored blue for the points, because those points aren't perhaps as important as the general trend. And then I would use the solid or more dark color to draw the trend. And perhaps I could emphasize that further by making the line a little bit thicker. This is my imagining of what that figure could look like, and what I want to build out with you today here in R Studio. And as always, if you want to get the code that I am developing, you can go down below in the description. There's a link to a blog post where you can get this code. There's also a link to the original paper, as well as a link to a newsletter article that I sent out to my subscribers, kind of describing how I would go about implementing the original version of the figure, along with some of these critiques that I've already mentioned. And if you're not subscribing to that or this channel, come on, man, get it together. Subscribe. All right, enough said. So again, I'm going to go ahead and load the library. And then this is simulated data that I've kind of picked off from the plot. It's not the exact same as the data, but it's good enough for our purposes. So I'll go ahead and take CU4 and bring that down. And we'll pipe that into ggplot, AES, for the aesthetics that we're going to map to the columns from CU4 to the different aesthetics. So on the x-axis, we're going to put copper. And on the y-axis, we're going to put the fluorescence, F-L-U-O, fluorescence. I always misspell that thing. And then color, I'm going to make treatment. And then let's go ahead and do geom point. So something's not quite right. We've got on the x-axis, of course, our copper, the y-axis fluorescence, and the color is treatment. For some reason, I put treatment in quotes. And so when you put treatment in quotes, that means that you want the word or the string treatment to be the variable. That's not what I want. I want it to be the variable treatment. And so then you remove the quotes. Let's try that again. And so now what we see is that we've got our two different colors. And as you can see, if we put this on a linear x-axis scale, that we have a lot of separation, right? So this is 3 and this is 300. And so that doesn't quite look right, right? One solution to that would be to put everything on a log 10 scale. And so we could do scale x log 10. So this gives us a warning that log 10 transformation introduced infinite values. So we'll come back to that in a minute. So putting things on that log scale does a much better job of spacing things out. So this is where we had the 0.01. This is where we had the 0.03, and then the 0.3, and then this here would be the 3, and then this would be the 3, and this would be the 30, right? There is no 3, which is why there's a gap in the data. And then over here, we've got some points here that are all piled up on top of each other. And so again, we said this was the 0.003. And so what these points most likely are is the 0, right? And so if you take log 10 of 0, you're going to get negative infinite, right? And so this is what's going on here. And so what I would do is go ahead and add a small number to that 0, right? And so instead of making that 0, I'm going to have it go down another log, right? So maybe I'll make this 3 times 10 to the minus 4. So I'm going to go ahead and add that into the pipeline where I'm making the plot. We'll do mutate, and we'll do copper equals, and I'll say if else copper equals 0, then I'm going to make it 3e to the minus 4. Otherwise, it's going to be the value of copper. And then we'll pipe that into ggplot. So now that warning message goes away, and we now see our points here for the 3e to the minus 4. But of course, there isn't a 3e to the minus 4. That's really our 0 value. So I'm going to go ahead and save all this out to a file. And so we'll do ggsave, and I'll call this line plot dilutions .png, and I'll do width equals 7.5, height equals 3.68. Those are the dimensions that I use to recreate that other figure. That looks great. One of the things I wonder, though, is now that we don't have side-by-side box plots, if we can't make the figure a bit more narrow, right? It doesn't need to be so wide because we don't have so much information that needs to be shown. So we'll come back to that in a bit probably, but I do think we could probably pull that in a tad. So the next thing that I always like to do to make myself feel better about making progress is theme classic. I think before with the other plot, we used theme BW for black and white. And so I don't know that we really need kind of the full box like we had with the theme BW. And so I think that looks pretty good. So one other thing I'm noticing with these values at 0 is that there's actually 6 points here, but they're over plotting on top of each other, right? And so something we can do instead of geom point would be geom jitter. So this is giving us jitter then. It's perhaps too much jitter because I'm noticing here kind of in the middle at the 0.01 that it's really wide, and you kind of get the sense that it's bleeding over into this other data. And so the challenge with using geom jitter in a case like this, where we do have a continuous axis, is that the jitter isn't supposed to be meaningful. But we do want to jitter things so that the points don't fall right on top of each other, right? And so we could come back up to geom jitter and do like width equals 0.01. So that, of course, brings things in, but that's not jittered enough. So let's maybe go up to 0.05. So now I'm noticing the overlap at my 0 copper values of that teal and salmon colored point right where my crossbars are, right? And so I think jittering alone isn't enough. I think what we'll want to do instead is to change the position. So we'll do position equals position jitter dodge. It is the hardest function for me to say, position jitter dodge. Anyway, and so now what we can do is jitter width and dodge width. So we can do jitter width, let's do 0.1, and then let's do dodge width equals 0.1. And so we still see a bit of overlap here between the two sets of points. And so maybe what we could do instead of dodge width of 0.1, let's try 0.2. So that gets them separated a bit, but I think the jitter width is still too wide. Let's drop this down to 0.05. So of course you could play with the jitter width and the dodge width to kind of get the look that you're going for. There's still a bit of overplotting in some of these. Something what we might think about doing would be to change the symbol. So we could do shape equals 21. And let me kind of get these to go across multiple lines. And then we could do color equals black. Here we could do fill equals treatment. And so now you have kind of circles around it, and you can kind of see, like in this case, that you've got 2 points that are separated from each other. But ultimately, again, I'm going to want these points to kind of, I think, kind of fade into the background. And so I think I'd rather have more jitter and less black. So let's go ahead and turn this back to color equals treatment. And then I'm going to drop the shape equals 21 and the color black. And let's see how this looks. Again, there's a bit of touching, if you will. So maybe we could increase the dodge width to 0.25, and that gets pretty decent separation. We can still see that the points kind of overlap with each other a bit. So one other thing we might try would be to change the size. Let's do size equals 0.5, and that gets very small points. This would certainly work for kind of blending things into the background. I think with the original plot, those points were a bit smaller than kind of the default plot size. One other thing that I want to touch on with geom jitter is that it's randomly applying a jitter, right, to the x-axis. And so we can set the seed, right? So we could do set seed, and then put in your favorite seed. I always put in my birthday because I'm vain that way. And so if I run everything and then run it again with the seed, I get the same plot, right? It gives me the same thing over and over again. So with this seed, I'm liking the spacing that I have here in all of my points, and I think that is going to work pretty well. Now what I want to do is draw the line through the points. And to do that, I'm going to be using a tool that I feel like I've been using a lot in these episodes lately, which is stat summary. And so we'll go ahead in here then and do stat_summary. So we need to give it the geom as well as the function that we're going to use to basically calculate where the line should be, right? And so now what we can do would be geom equals line, and then we could do fun.data mean_se. I don't care about the standard error or the standard deviation. In this case, I might go back and forth on whether I want the mean or the median. So let's try this. So this draws the line through the data, and I think that looks pretty good. Again, that is the mean. If we wanted the median, we could probably use fun on its own. That calculates the y, and we could do median all that, right? And so the median will go through that middle point, right? And so maybe we'll stick with the median. So one thing I'm noticing though is that the jogs in the line aren't really centered on our jittered points, right? And so I want to try something. I don't know that this will work, but we could do position equals position dodge. And then the dodge width that we used before was 0.25. So let's try dodge equals 0.25. And let's see if that dodges the X position of our lines. And nope. And I think it's probably the argument we want is width. Yeah, it's width. So let's use that instead. So because I think, yeah, this was dodge width, not dodge. So we'll do width. So now we see that the jogs in our lines do overlap with the center of our jittered points, right? So I'm going to go ahead and make our line a little bit thicker. And I think we can do that up here in stat summary. We can do line width. And let's do 1. I think by default it's 0.5. So this gets us our line on top of our points. So I think we're well on our way to regenerating the plot. We certainly have the lines and the points in here now. Let's go ahead and add our x-axis labels. I think I might go back to using the 3s rather than the powers, direct powers of 10. And so we can do that here in scale x log 10. And I'm going to have the limits, let's do limits from 1e to the minus 4, go to 1e to the 3. So let's try that. And so that gives us lots of room on either side, which I think is probably too much. Why don't we go ahead and remove the expansion on the x-axis? And we can do that here with expand equals C00. So I think that gives a better border on either side of the data. Let's go ahead then and modify the appearance of our x-axis labels, right? And so we'll do that in here. And so we'll do that here in scale x log 10. We can do breaks, and we'll do C3e to the minus 4, and then we'll kind of go up from there, right? So 3e minus 3, 3e minus 2, 3e to minus 1, 3, 30, 300. So that gives us all of our breaks. Of course, this is supposed to be 0, right? So let's go ahead and make that 0, and we can do that with labels. So we'll do labels equals 0, and then I'm going to, for now, copy all this, and I got an extra comma there. All right, good, and I think that gives us pretty nice spacing. I would like to put a line, a vertical line, in between our 0 and the 0.03, as I kind of illustrated here in my hand drawing, right? So we can do that with geom vline. I think I'll have that on top of all my other data. So we'll do geom vline, and we'll do x-intercept equals, and now I don't really know what it should be. Let's make it 1e to the minus 3, and we can adjust to kind of get it centered between our 0 and our 0.003. I think that actually looks pretty good in terms of placement. And yeah, I think we'll roll with that. So I'm going to modify that now to make it gray and to make it dashed. So we'll come back up to geom vline. So let's do color equals gray. Let's do line type equals dashed. And I'll go ahead and change the line width. So we'll do line width equals 0.25 to make it a bit thinner. So that might be too thin, right? So let's take that back up to 0.5. I think that looks great. So one thing I'm noticing is that our points, especially the median points, are falling behind the line, and it's really hard to see that it's there. We could perhaps make the points a little bit larger, but I was trying to get away from making those points so prominent. So maybe I could make them a bit bigger, but change their alpha so that they're not so rich in color, so that they're kind of wash out a little bit. So let's go ahead and remove the size. And so that gets us the big meaty points. And then let's go ahead and do alpha equals 0.5. And so, yeah, that kind of gets the points to fade into the background a little bit. What happens if we do alpha of 0.25? Those wash out a bit more. And I actually kind of like that. I think we'll roll with that. What happens if we put the points on top of the line? I don't know that it's going to look any different. So we'll try. Again, a lot of this is experimentation and seeing what works well and what doesn't. That really looks no different because the circles have that level of transparency, and the line, the opaque line going through them is just going to make it look more opaque, right? So I think that's fine, and I think we'll roll with that. But I'm not a fan of these default colors, so let's go ahead and change our default colors. And so we could do that with scale color manual. So I'll put that down here below my scale X log 10. So we'll do scale color manual, and then we'll do values. And so I like to think about the psychology of color and what the colors mean. And I kind of feel like this 7H4M is a bit of a control as I understand it, whereas the CLPB 17 is more of like the experimental factor showing the, I think, loss of activity or the loss of genotoxicity, right? What happens if we make our 7H4M line black, or let's make it gray actually, and then make this line like a really strong color. So let's do gray, and then let's do navy blue. All right, let's try those. And so now what we see is that, yeah, the control kind of fades into the background, and the control is the control, right? It's kind of like this zero copper. And then the experiment that we're really interested in is this stronger color. And I actually kind of like that. Because it's decreasing, blue kind of works. We could maybe try a different color blue. What happens if we do straight up blue? So I think that looks pretty nice. Let's go ahead and modify our legend. So let's go ahead and move our legend in. I think I'll also want to modify the appearance of the key in the legend. So we can go ahead and start with labs. And for color, we can do null. And I put a comma instead of a plus. And as we've seen in the past, doing a name equals null removes the name entirely. Let's go ahead and move that into the plotting window. So we can do that with theme. We can do legend.position equals inside. And then we can do legend.position.inside. So I'm trying to remember what we did last time. I think it was 0.9, and maybe it was 0.8. Okay, it wasn't 0.8. That's the position on the y-axis. Let's move that down a bit. Let's try 0.6. That moves it down. We can go ahead and put a black ring around that by doing legend.background and then element rect and then color equals black. And so that color equals black on element rect is going to make the border black. So one thing I'm noticing is, as I mentioned at the beginning of the episode, this is really wide, right? And I don't think it needs to be so wide. It was wide because it had those double box plots. So let's see what happens if we bring it in a bit. And so we can do that, of course, with the width. Let's take that down to 5 and maybe make this 3. And so I think that is nice in making everything a bit more compact. And yeah, let's go ahead now and move the legend in a bit. And I want to make the border around it smaller. So I'm going to have the X position be 0.8. And then let's go ahead and do legend.margin. We'll do margin. And I'm going to start with like ones all the way around. Pretty good. On the right side, it seems a bit tight. So remember, it's TRBL, trouble. So let's make this 2 on the right side. And so I think that's pretty good. So I think the key height is adding some margin to the top and between these. So let's go ahead and change the legend.key.height, and we'll do unit of, I don't know what it should be. Let's try 10 and then PT as the actual unit. You'll see that that then removed a lot of the space between the two values, as well as the spacing at the top and the bottom. And so I think that looks pretty nice. One thing I would like to do is make the line inside the legend a bit more narrow. So let's go ahead and see if we can do that. We can do that, I think, within scale color manual, and we can then do guide equals guide dot underscore legend, and then we can do override AES, and we then give it a list, and we can do line width. Let's try 1. All All right, that's, I think, what it was already. So let's make it 0.5. And so that makes the line a bit thinner. Let's maybe make it 0.75. I like that. I like that 0.75. The other thing I'm wondering about with this plotting symbol is if the alpha should be 1. Again, this is all experimenting to kind of give it an aesthetic, an appearance that resonates. So we'll do alpha equals 1, and then that gives us the solid plotting symbol. But I don't know. I feel like our plotting symbols here aren't a solid alpha. So maybe I'll go ahead and remove that, and we'll only modify the line width. So let's go ahead and clean up our code a little bit so it doesn't scroll off the right side of the screen. And I want to go ahead and take on our labels. And so on the x-axis, we had copper concentration. We could do square brace CU like I had in my illustration, but I think that's too jargony. And so then what we could do here would be the UM for micromolar. Don't worry, I'm not going to leave it with the U. We'll come back and we'll actually put in the Greek letter. So on the y-axis, we'll go ahead and put fluorescence. And that we'll do is percent of 0 UM CU. And that looks pretty good. Now let's go ahead and change that U to an actual Greek mu. So we can replace that U with a Unicode value for the Greek mu. I do not have these values memorized, so I always have to Google them. So we'll do Unicode mu. I've searched for this before, and I think it is U03BC. So we just need those last 4 characters, and we can then come in here, and we'll do a \U for Unicode, and then that 4-digit code, right? And we'll need the same thing down on this line. Now we get our Greek mu on the x-axis. So I'm pretty happy with the way this looks. I think this would be worth publishing. I think this would be a publication quality figure, and I think it looks pretty good. I don't totally know the biology behind this paper, so some of the decisions I've made along the way might not resonate with the story that needs to be told, right? Like, so the decision to make this line for 7H4M a gray color, to have it be more of a muted presence in the figure, is based on my understanding that this is a control, and really that it doesn't change from 100% is indicating that like nothing's happening, right? It's more of like a negative control, right? And so I don't know that that should be given as equal weight as kind of the experimental treatment, right? Where you increase copper and you lose this activity of CLP, right? So anyway, that's my decision, and you can make of that what you will. I think we got pretty close to my initial vision of what I wanted to do in terms of drawing this out and then recreating my drawing. I would really encourage people to try to draw their plot before they go about plotting it, because once you have something that you can look at, you can go about saying, well, these are the pieces I know how to do, these are the pieces I don't know how to do, and you can then attack the pieces that you know how to do first, and then come back to those other things later. And you could kind of point to things and say to somebody, this is what I want it to look like. Can you help me get there, right? So anyway, I would encourage you to take on that strategy. Of course, we can compare our version back to the original version that was published. Let me know what you think, which one you prefer. I really do feel like my version is the better version of the two. But of course, I made it, so I'm of course biased. But I think subtle things like putting in this dashed line to help emphasize that these are the controls, getting rid of the box plots, which I think kind of confuse the story or just kind of clutter things up. Putting things on the log X scale does things to kind of better incorporate the 0.01 and the fact that there is no data for 3, whereas here you kind of think everything is equally separated, or at least separated on log scale, when you've got kind of that 0.01 thrown in here as being kind of equal spacing between all the other variables. So I would love to get your feedback on these two plots. Let me know what you think looks good or what you would do differently. I would love to get a sense of your sense of style. I'm obviously sharing with you my sense of style, and that isn't necessarily everybody's, which is cool, right? We all have the right to be a little bit different from each other and kind of see the world through different lenses. Please share what we're doing here with your friends. Please make sure that you've subscribed to the channel, and we'll see you next time for another episode of Code Club.